Excellent. Okay, so hi everybody. My name is Graham Faiz. I'm the Innovation and Digital Lead at DNV. Thanks for the invitation to present at this week's call, where Will and I will talk a little bit about our work with gas network SGN to explore a digital twin of the gas system of the future. A very brief introduction to DNV. We're an independent assurance and risk management company. Sadly, Peter Phillip of Gas Distribution Network SGN is unable to join this call today. Well, I'm delighted to welcome my DNV colleague, William Osborn, who will stand in for Pete and present the use cases and prototype slides in just a few minutes. Some of you may recall that earlier this year, Peter and I presented the initial phase of this project, exploring how a digital twin of a low carbon hydrogen production system attached to a real world use case in SGN's H100-5 project could ignite innovation in the gas industry, improve operations and reliability, and help balance supply and demand in a future hydrogen-based system. This discovery phase ran as part of the Ofgem Strategic Innovation Fund, and since that time, we've successfully progressed the project through to the alpha phase. And in this particular phase, the production twin concept has been joined together with another discovery phase concept that SGN were running, exploring a digital twin of the gas distribution network. So effectively, we've created a project that we're now calling a digital twin of the gas system of the future. Project partners are National Grid Gas Transmission and Metering, National Grid ESO, Amazon Web Services, IBM and Esri, in addition to ourselves. We believe this is a true connected digital twin concept, and really our aim throughout this project, and as we draw this alpha phase of the project to a close by end of January, really is to create 3 connected digital twin prototypes rooted in different parts of the gas network or gas system. The production of green hydrogen, the local authority looking to understand gas capacity or connections, and a high pressure network manager who works with variable high demand customers such as gas-fired power or peaking plant operators. Working closely with National Grid ESO, we're also aiming to provide some valid and real-world use cases, gas industry use cases, for the ESO's virtual energy system concept, which is shown on the right-hand side of this slide. In terms of methodology, we've been working with IBM's client engineering team and using their value engineering method, creating a number of epics, features and user stories, which ran throughout the course of October and November of this year. And that's resulted in the creation of 3 prototypes, which we've since played back to end users and other project stakeholders. We've also worked with the Open Data Institute using the ODI's data ecosystem mapping methodology to understand the current and future exchange of value through data and the data that needs to be made available to enable the value creation to happen. In terms of an assurance framework, we're using DNV's recommended practices for the qualification and assurance of digital twins, along with its underlying data quality and governance assessment framework to ensure that the deliverables of the project are useful, meaningful and usable. And really the output from this work package will effectively be what we call a draft statement of capability aimed at providing an objective narrative describing the fitness for purpose of the developed solutions from both IBM and AWS should they be deployed into SGN's business as usual during the hoped for next phase of the project and beyond. And a systematic strategy for managing data quality challenges has already started to be developed and defined via a series of interactive workshops with SGN. So that's the frameworks. I'll now pass to Will to talk you through the use cases and show what we've created. Will, over to you.
Thanks, Graham, and hi everyone. So at this phase of the project, we've actually considered 3 personas. The first is Roger, who's a high pressure network manager at SGN. And his role is basically around managing the demand for day ahead of natural gas from the national transmission system, something that becomes a problem when things like peaking plants come online intraday and mess up that demand profile. Secondly, we have Alex, who's a hydrogen production manager. So his role would be around managing the production of hydrogen at localized sites throughout the UK. And finally, there's Helen, who's a local authority planner. And when developments are coming up in the area that she is in control of, she'll have to look into how the current gas system infrastructure is acceptable, is prepared for those sort of developments to happen. Okay, can I have the next slide, please, Graham? This is the kind of tool that we've created for Roger. So it's built on Esri, and it allows him the ability to look into each 3 of his the gas zones that he looks after and see the positions of the peaking plants. From this, you can also see the overall demand at the peaking plants in that district require. And also, hopefully in the future, we'll be able to see their active status and their planned operations within the next 24 hours, so we can accommodate for that in his gas network. Go to the next slide, please, Graham. And this is Alex's tools. This was actually built on AWS TwinMaker. And from here, you can see the four what they're called, 4 displays you can see. The first is looking at the overall operation of the site, so whether the electrolyzer status and overall storage on the site. And the bottom left shows things like demand profile, renewable energy production, and the cost of grid electricity should it be needed. And the top right shows the hydrogen production methods, whether it be through green hydrogen through a local turbine, or through grid, or blue hydrogen for a local grid connection. And the final one allows for the user to change things like the minimum storage capacity to optimize demand for the intraday operations. Next slide, please, Graham. And finally, we have Helen's tool, which again was built on Esri, but is linked to a DNV tool called Synergy Gas, which allows for checking of the gas network utilization. As you can see a video running, the user can draw an area, and then the tool can quickly identify the nearest possible connection point. And once that is identified, they can input a demand profile. This stage we just put 3 simple things, 3 property types. And then this is when the tool is now running a request to DNV's solver tool, and it's assessing the gas network at that point to know whether there is sufficient capacity. And at the very end, you see it flash up saying it's all good. In the future, the main thing we're trying to develop here is the ability to do a least cost path analysis. So that'll take into account things like roads, railways, rivers, to then allow for analysis to be run to find the least cost option for infrastructure. Next slide, please, Graham. And yeah, so the next steps of the project, we're finalising our prototypes currently and readying them for development early next year. We're running a number of stakeholder engagement workshops, both within the partner organisations as well as more widely in the industry. And then we're finalising some material that we aim to publish early next year before the end of the alpha phase. And then also finally, being a SIF alpha phase, we're hoping to apply for beta phase come March next year. And that concludes. Great. Thank you. Thank everyone for listening.